Okay, so the first equation right here, we have the general form written out like this. Now, when we take a quick glance at this equation, we all should be able to tell what shape it is, of course, other than the fact that there's a hyperbola printed at the top. So how can we tell that it is a hyperbola? Now, for circles, we said that the coefficients for x squared and y squared will be the same. That would be the way to tell how they are circles. For ellipses, we say they are different, but they are both positive numbers. But for hyperbolas, we'll say, well, yeah, so they are different. So the coefficients are different. Coefficients of x squared and y squared are different and with opposite signs. Okay. And the sign becomes a very, very important signal for us because whoever that's positive gets to call the orientation. So in this case, we see the y square being the positive one, and that means we are going to have vertical hyperbolas. Then we do the same thing that we have done previously. Okay, we will rearrange the terms so that we can have an easier time to do completing the square. Now, for this particular one, be very careful when you do the factoring, because for the second one, it is a negative coefficient. So when you take out the -9, make sure that you take care of the sign inside the parentheses. So you have x squared plus 6x. Okay. Now, I also want to clarify something when we do completing the square. Now, it's not just procedures. It's also based on some very fundamental understanding that whatever you do on the left, you must do the same thing on the right. So to complete the square, we're going to add 1 inside the first pair of parentheses here. And if you add 1, on the other side, we will add 16 because it's 16 times 1. For the second pair of parentheses, we have x squared plus 6x. Therefore, we will need to add 9. Now, there's a coefficient of -9 sitting outside the parentheses. Therefore, we will need to subtract 81. Okay. Now, there was a student last week asking something, well, showing me some work on this. And the student was able to do the addition over here without writing anything on the right-hand side. And she was asking me, how do I get the equation? I said, do the completing the square correctly first. If you do it correctly, you will get the equation. But she was so driven to get the final standard form without understanding the details of the process. And of course, if you disregard the process, you will not get the end result properly. So you have y minus 1 square for the first pair of parentheses. And then for the second pair of parentheses, you will have x plus 3 square. Again, do not forget the square. Do not forget the sign in the middle. Okay, on the quiz last week, I saw some students being a little bit absent-minded, and they forgot to write down the sign in between the two parentheses. So we have 209 plus 16, which gives you 225. And 225 minus 81, 144. Okay. Oh, here's another good question. Well, good question. So the same student asked me, so how do you get the denominators? I said, do you know why we have the denominators? And she said, well, you get the AB values, right? I said, yeah, but do you know how? Well, how can we have fractions? Because we're dividing both sides by 144. And the reason why we divide both sides by 144 is because, well, the right-hand side has to equal to 1. That's the standard form. So it's not like a magic, somehow the fraction would appear out of nowhere. It's just that we need to get the right-hand side equal to 1. And so we have y minus 1 and x plus 3 for those two parentheses. And then for the fraction, the reason why we have a fraction is because we have 16 over 144. Well, 16 times what is equal to 144? Well, 16 times 9. So 16 over 144 becomes 1 over 9. So that's why you have a 9 down below, the y minus 1. And then 9 over 144, it's the same thing as 1 over 16. So for students who did not pay attention to the process, they would think that, oh, so the numerator, the coefficients were just somehow swapped among the two fractions. I mean, it definitely looks like it, but the reason why they are swapped is because of the division. It's just what 16 over 144 is. It's just what 9 over 144 is. So at this point, we can write down something. We can write down our center. We can write down our A value and B value. Where is the center? 1, -3 is not correct, unfortunately, because the x and y are switched. So this is where you have to be very careful. This is y minus 1. That means the 1 is for the y coordinate. X plus 3, that means the x coordinate is -3. Okay, so be careful. Don't just go to the second value here. Don't just look at the numbers, look at the whole thing. And the A value is always the one sitting up front in the first fraction. So A squared is 9, so A is 3. B squared is the denominator of the second fraction. So B squared is 16, so B is 4. So now we have some good information here. So first, let's go ahead and plot our center. We have -3, 1, right there. That's our center. And we know it's a vertical hyperbola because the y term is sitting up front. So A is the distance from the center to the vertices. So that means I would go 3 units up and 3 units down for my vertices. And to write down the coordinates, well, I know that they are vertical, so the x coordinate would not change. So I'll write down the -3 for both points first. And then it's 3 units up. So 1 plus 3, it's 4. 1 minus 3, it's -2. Okay, so I can cross-check with my graph to make sure that my vertices are okay. And then we have the B value, which is the endpoints of the conjugate axis. So B value is 4. So you have 1, 2, 3, 4, 1, 2, 3, 4. Okay, so you have the B value here, and right here. What you can do is this: once you have the A and B values, you draw the dots. You can go straight ahead to draw the box. And not only you draw the box, you draw the diagonals too. because the diagonals will be your asymptotes. Okay. And you will you draw a graph like this. Okay, making sure that after you draw the graph, match with ask yourself, does it match with the sketch? Okay, are you drawing a vertical hyperbola, a pair of vertical hyperbolas? Okay. The endpoints of the conjugate axis, which will be these two, they sit at the same y value. So it will be to the right 4 units. So -3 plus 4, it's 1. -3 minus 4, it's -7. So you have the endpoints of the conjugate axis. C, well, what's the relationship between A and B, A, B, C again? C squared is equal to A squared plus B squared for this one. So A squared is 9, and B squared is 16. So C squared is equal to 25. So C is equal to 5. So if you want to draw the foci, that will be 5 units up and 5 units down from the center. Okay, 5 units up and 5 units down from the center. So the foci would be having the same x value, and up 5 would be 6, and down 5 would be -4. Okay, lattice rectum, it's 2b squared over a, so 2b squared is 16 over a, so that is 32 over 3. Just leave it as an improper fraction. All right, last but not least, we have the asymptote. So what's the asymptote here? Well, y minus the y coordinates of the center, which is 1, equals to the slope. We'll take care of it in a moment, plus or minus. Okay, and then we have x minus -3, which is x plus 3. So now slope time. So what is the slope of the asymptote here? Now let's just go ahead and take a look at this. So look at this asymptote right here. Rise over run. Rise. Is it A or is it B? It's A. Run, it's the B value. So that means your rise is A, your run is B. So you have the slope of A over B, which is 3 over 4. And after you write it, okay, you should double check with your graph and say, well, right here, is it 3 units? Yeah. Is it 4 units? Yeah. And that's how you can confirm that it's plus or minus 3 over 4 for the slope. Again, the numbers right next to x and y are the coordinates for the center. So a fair comment is that it is extremely tedious to draw all these things. And that's why I urge you not to wait until the very last day. If there's a way that could be safely done at the very last day, I would say, sure. But I don't want you to suffer. And that's why I would say, just get it done. Okay, just get it done today, tomorrow, and tomorrow you all don't come back until what? When? 10:40 or 10:45? 10:45. So so use the time to practice all these hyperbolas. So on Wednesday, when I see you again, I expect that everyone can draw. Everyone can draw, label, and write down these equations. Okay. So now let's go ahead and do the bottom one.